Today's lesson is going to focus on writing equations. So we've already talked about solving one-step equations and two-step equations. Now we're going to look at, given a sentence or a phrase, how we can set up an algebraic equation. These equations are only going to focus on one-step equation. So there should be one operation and one step to solve. So first off, we have created a chart here like the one that we had with expressions. It just looks slightly different. We've combined the addition and subtraction in one kind of chart. We put the subtraction on one side and addition on the other, but it's all in one chart because, as we know with equations, if we have addition in the equation, we subtract to solve. If we have subtraction in the equation, we add to solve. So they kind of go together, and we have to think a little bit differently when we're setting up the equation. And then we only put multiplication here because we're only going to be giving you equations that have multiplication in the problem, and then you divide to solve. We're not going to give you any equation that has division in the problem. So let's look at the steps to solving or to writing equations. So I want you to highlight some keywords in here. Step one is we are first looking for the unknown variable. What are you solving for? A lot of times in the question it's going to say how many and then some unknown value. Okay, and then we're defining that variable. Then I want you to identify key information, and by that what we're really going to be looking is for you to circle all the numerical values. And then step three is that we want you to highlight the operation. So that's when you're going to be using your chart to figure out what words tell you which operation. And then to determine what the total or end result is. And you're going to set your equation equal to that value. And then the biggest thing that we want you to think about here, because you guys can solve a basic word problem. You've been doing that for a long time. But what we're trying to focus on right now is making your equation algebraic. So I want you to look at these two examples here. This one on the left is an algebraic equation. That is what we want you to do. We've got the variable on the side with an operation and a number, and the equation's equal to just a number, not a variable. Over here, this is not algebraic. You don't want the variable alone and equal to some numbers. So this is not what we want. We want something like this equation here. So let's start with number one. Define a variable and write an equation for each problem. So again, right now I want to go through and look at the important information here. So example one, 3 more than a number is 12. So first thing I want to do is I want to underline my unknown. We don't know what the number is, so I'm going to say that n equals a number. Okay, so first we defined our unknown. Now I want to circle the numerical values. 12 is easy to spot. Then I also see that it says the word 3, which tells us a number. Okay, and then I want to highlight the word that determines the operation. So I see the words more than, which tells me addition. So I'm going to put a little plus up here. So I know that I have addition in the problem. So 3 more than a number. Remember, whenever we have the word then, it means it goes after. So I'm adding 3 to something. What am I adding it to? I'm adding it to n. And then the word is here clues us into the equal sign. So it equals 12. So our equation is n plus 3 equals 12. Eventually, on the homework, we're going to have you solve the equations. Right now, we're just focusing on writing them, so I don't need you to solve that right now. Example 2, the product of 7 and a number is 28. So what I want you to do is to underline our unknown. We don't know what the number is, so I'm going to define the variable n equals a number. Then I'm going to go back, I'm going to circle that key information. I see the number 7, and then I see the word 28 that tells me the number. What I actually want to do here is I want to look for what my total or end result is and set my equation equal to that. So is 7 my total or is 28 the total? Well, I see the word is, it says is 28, so I know my equation is equal to 28. So I'm going to do that first. Now I'm going to go back. I know that I have to use the number 7, but I need to look for the word that tells us the operation. If I look at my chart, I see that the word product tells me multiplication. So what is it the product of? It's the product of 7 and our unknown number. And remember, when we write multiplication, I'm just going to write the number next to the variable. So we have our equation, 7n equals 28. All right, example 3. The total time it takes Dan to mow one lawn is 15 minutes. Last weekend, Dan spent 165 minutes mowing lawns. How many lawns did Dan mow last week? So again, first thing I'm looking for is the unknown. Generally, I'm looking for the last sentence. Not always, but usually in the last sentence, it's going to ask us the question. And in this case, it says, how many lawns? We don't know how many lawns. That's what we are solving for. That is our unknown. So defining the variable, we could use L for lawns, but that might look like a 1. So I'm just going to go to our default variable of x and say that x equals the number of lawns. Now I'm going to go back. I'm going to circle the numerical values. So I see 15 and I see 165. And I want to first determine which one of those is the total. So did he mow the lawns for a total of 15 minutes, or did he mow the lawns for a total of 165 minutes? Well, if I look at the problem, it says he spent 165 minutes, so that's our total. So I'm going to set our equation equal to 165. Now I'm going to go back, and I'm looking for the words that clue us into the operations. So if I look at my chart here, one of the key words that I want you to look at for multiplication is this part here where it says 1. For example, how much for one item? That is actually kind of similar to saying per item, for every item, for each item, okay? So the word 1 is cluing me into multiplication. And if I look at this problem here, it says the total time it takes Dan to mow one lawn. That right there clues me in that this is a multiplication problem. So I have the other number that I haven't used yet, which is 15, and x is our variable. So one lawn is 15 minutes. So it's 15 times x, which we are just writing as 15x. All right, number 4. PETA uses 7.5 cups of flour to make 3 loaves of bread. Of banana bread for Katniss. How many cups does it take to make 1 loaf of bread? So again, when I'm looking for my unknown, generally I'm looking for where it says how many, and that's usually in the last sentence. So here it says how many cups. We don't know how many cups. That is what we are solving for, so I'm going to define my variable. I'm going to say C equals the number of cups. I'm going to go back. I'm going to circle the numerical values. So I see 7.5 or 7.5, and I see 3. Which one is our total? Okay, so did he have a total of 7.5 cups or 3 cups? Well, the 3 is talking about our loaves, so that's not going to work. We're just looking at that it's 7.5 cups. So that is our total there. So I'm going to set my equation equal to 7.5. Then I'm going to go back and I'm going to look for that key information. So again, in this instance, I see that it says, how many cups does it take to make 1 loaf? So that word 1 clues us in to multiplication. So we are going to multiply our unknown variable c by the other number that we haven't used, which is 3. So 3c, because there's 3 loaves times how many cups per loaves equals a total of 7.5. Number 5, Lisa is cooking muffins. The recipe calls for 7 cups of sugar. She already put in 2 cups. How many more cups does she need? So first thing, looking for our unknown, I look at that last sentence. It says how many more cups? So our unknown is the cups. That's what we are solving for. So again, I'm going to say C equals the number of cups. I'm going to go back. I'm going to circle the numerical values. I see 7. I see 2. which one is the total? Does the recipe call for 7 cups or 2 cups? Well, it says right here, the whole recipe calls for 7 cups. So I'm going to set my equation equal to 7. Now I'm going to go back and I'm going to look for the word that clues us into the operation. When I scan through, I see that it says, how many more? Remember that the word more, if we use our chart, tells us addition. So I know that I'm adding my unknown variable with the other number in the problem. She already put in 2 cups. So we have 2 cups, plus we need to add some more to get to our total. So the more that we're adding is our unknown amount of cups. So you have 2 plus C equals 7. Number 6, how many lollipops can you buy for the Valentine's Day sale if you have $26 and each lollipop costs $2? Okay, first thing, I'm looking for my unknown. This time it's not at the end, but I see the words how many, and it says how many lollipops. So our unknown, what we're solving for, is the number of lollipops. Again, an L looks like a 1, so I'm just going to say X for lollipops. X equals the number of lollipops. Then I'm going to go back. I'm going to circle the numerical values. I see 26 and I see 2. So how much money do you have? Do you have $26 or 2? Well, it says you have $26. That is our total amount. So I'm going to set my equation equal to 26. Now I need to go back and find the operation. So if I'm looking and if I'm scanning on my chart, I don't see the word per or for every, but for every is kind of the same thing as each. So I'm going to add that word in there right next to it. So that means the same thing as per and for every. So that's the word I'm going to highlight, and that tells me that it means multiplication. So we're going to use the other number that we haven't used yet, which is 2, and multiply it by our unknown x, which is the number of lollipops. So 2 times x is just 2x. All right, one more, and then I'm going to give you the you tries. So last week, Julia ran 30 miles less than Emily. So let's find our unknown. It says if Julia ran 47 miles, how many miles did Emily run? So how many miles did Emily run? That's our unknown. So we're talking about miles, and we're talking about the number of miles that Emily ran. You could use M, you could use E. I'm going to use E so I know that we're talking about Emily. So E equals the number of miles Emily ran. Now I'm going to go back, circle my numerical values. I see a 30, I see 47. So what is the total amount? We're comparing this to Julia. So did Julia ran a total of 30 miles or 47 miles? If we look right here, it says Julia ran 47 miles. So that's our total that I'm going to set our equation equal to. Then I'm looking for the word that tells us the operation. I see that it says less than. Less than means subtraction. And remember, we have to be careful with subtraction because the order matters. Remember that the word than means that it has to go after. So we are subtracting 30 from something, not doing 30 minus something. And what are we subtracting 30 from? We are subtracting it from Emily. All right, our you try. For the first one, you're going to fill in the blank with 40. And the second one, you're going to fill in the blank with 240. For this one, we want you to not only define the variable and write the equation, but we also want you to solve before you get it checked.